Potential energy is referred to as stored energy. One type of it is the elastic potential energy. This involves a spring which has potential energy when it is stretched or compressed. For when it is released, work can be done on the object to which it is attached to. This experiment will aim to determine the spring constant by means of a force displacement graph with the help of a Yakult bottle and a spring.
First, the necessary materials and equipment for the experiment were gathered. This includes a metal spring, colored sand, Yakult, bottle, top-loading balance, T-square, and stand. Then, the length of the metal spring was initially measured. Table 1 shows the mass that was weighed in order to acquire the needed force. As the needed mass is put into the Yakult bottle, it was made sure that there was no spill. The top-loading balance was calibrated and the bottle was put on top of the balance.
The mass was recorded. Next, the bottle was hanged in the spring, and the spring was hanged in the stand. The length of the spring was measured using the T-square. This is repeated until the 10 trials are done. Lastly, the recorded data will be plotted in a graph.
An experiment was performed regarding the determination of the spring constant. Using a set of unique materials, the determination of the spring constant was carried out. In Table 1, the force N in each trial was obtained by converting the mass m from grams to kilograms. Afterwards, the value would be multiplied by the acceleration due to gravity, which is equal to 9.8 meters per second square. The displacement x was obtained by subtracting the initial length of the spring from its length in each trial. The spring's initial length was 1.1 inches. Table 2 in the next slide shows all measurements of the length of the spring converted to meters.